container accomplishes the same goal as a virtual machine. It means that you are mutualizing hardware to deploy software isolated from each other. Well, isolated to a certain extent because you can define the communication rules, the security aspect of it. It's lightweight, much more light than a VM. I'm going to explain why in a second. Consequence of that is that it's fast to restart. Restarting a container takes half a second. Some containers take 0.1 second, whereas when you restart a virtual machine, it can take forever. You have to restart the whole operating system. You've got very powerful software isolation, and finally, it's portable, meaning that you can really transfer your Docker image from one host to another host with potentially different Linux distribution, for instance. So lots of benefits in the containers. So why should you care about the containers? Why do we think that you should move away from the old and legacy thing, meaning installing software in a dedicated host and going? So Docker is compatible with everything. So no matter what Linux distribution you want to use, you can use Docker. Docker is even compatible with Windows and Mac OS, but we're not recommending you to host it on it. The integration on Windows uses a virtual machine, so you've got the performance hit without any benefits. Docker is really designed to work on Linux, and I'm going to explain why. You've maybe heard about serverless architectures. It's a new form of architecture where you don't even rely on servers. Say you go to AWS, you don't have to purchase virtual machines. You just deploy your VMs. Of course, they are hosted somewhere on a data center on a physical host, but you don't have to take care about that. They handle the capacity planning. You just deploy containers, and whatever the size, they are going to find room somewhere to host them. Industrialization. Well, for hardcore ops people from the ancient world, that guy. Automatization can be done, of course. You have tons of technologies, Chef, Puppet, Ansible, that can automate things. However, you have to take into account the specificities of the OSs, the network, the type of machines you are handling. Docker makes things easier across all distributions. So automating the lifecycle of Docker images is really easy with the right tool. And finally, standardization. From dev to pre-production to production, you want the environments to be as close as possible to each other's. You want to be able to reproduce the bugs across all environments. Docker allows to do just that. Streamline the interactions between the devs and the ops, DevOps. You want to be able to, you want the devs to work so on the very same environments, but you want them to be able to try things as fast as possible and hand it over to the ops people, so improve feedback loop. You try your environment, you deploy it in production on pre-production. If the testers are not happy, it's very easy for the developers to just fix things, upload the outcome to a centralized repository, and then have the ops people redeploy it. Can be done in 10 minutes. Whereas with the old model, it could take much more time. So that's a quote from the Phoenix project. I don't know if some of you have read that book. It could be life-changing for some people. So it's basically a book about the DevOps world, how you should automate your organization to save time, limit the amount of extra work you have to perform for each project. So improving daily work is even more important than doing daily work. It means that if you have repetitive tasks across your day, you're just wasting time. So you better focus on automating everything and working on things that deliver value for your organization. The DevOps movement is doing just that, and the Docker ecosystem plus all the tools that go with it allow to accomplish just that. finally, and that one is a big topic, Docker and the container technologies in general allow to improve the SLAs. Why? Because with the same amount of resources, instead of allocating one server per physical host, you can actually mutualize the applications on the same host and multiply the number of containers. For instance, in the legacy world, you would have 4 servers, one database per server and 1 application per server, whereas on the Docker world, you can have the same number of hosts, but just put more containers per host. It means that on that schema here, if you lose one host, you still have replication. Whereas on this one, with 2 different applications, if you lose one server, you will not be able to serve traffic, for instance. So same hardware, but better mutualization of everything. So what is Docker? How does it work? We're not going to go in depth because we don't have a lot of time. But basically, it leverages the Linux kernel. So the Linux kernel has mechanisms to isolate the processes. So they have mechanisms to isolate the processes, the memory, the file system, so everything you see here. So compared to a virtual machine, it means that you have isolation on both fronts. However, when you do an operation on a virtual machines, most of the time it would be intercepted by the virtual machine, translated and protected against a security breach by the virtual machine before being executed. Of course, it's not the case for all the operations on the virtual machines, but it happens a lot. Whereas with Docker, since we leverage native things that are supported by the Linux kernel, you don't have a performance hit. And on our tests, Docker images perform the same way as physical hardware. So it's a big improvement compared to the virtual machine where we always measure a performance hit of at least 10%. Other difference on the Docker containers, you have to reinstantiate the operating system on each VM. So if you're running, I don't know, Debian, for instance, if you have 3 different applications running on VMs, you have 3 Debian distributions mounted using 3 times the memory, file system, etc. On Docker, everything is mounted directly in the Docker engine, so you don't have to reinstantiate your operating system each time. So you're actually saving memory, and Docker images usually weight around 20 meg to 1 gig, depending on the size of the application inside it. So again, restarting it takes less than a second. No kernel instruction abstraction. We've talked about it. The root of Docker is Docker files. So basically, you write a file that is being built. It generates an image, and from that image, and you can run that image as many times as you wish. So, for instance, we're going to provide Jahia DX images on the internet. So on Docker Hub, it's a public repository. In one command line, you can pull that image, install DX, and that's it. So the reusability of Docker is very important for us. Container as a service. So that's where we are getting at. First, some words. Container as a service is the same thing as container orchestration and the same thing as container scheduling. Okay, it's all the same, different terms. So why should we care about another layer? Because we're already doing great things. We're automating the installation of one piece of software, one Jahia DX, one database. So why should we care about one thing? Well, we're missing a few features. You might do capacity planning. You might have many servers, and you might want to automate the installation of the Docker image on the server that has more room for applications. You might want to automate the backup, the restoration. Maybe you want to automate the upgrade. That should ring a bell, by the way, because it's all the features that are integrated inside Jahia Cloud. Because yes, Jahia Cloud relies on Docker. It relies on container as a service, so it's no surprise. So you can actually achieve exactly the same goal as Jahia Cloud, but on-premise or in the cloud. That's a schema of, that's an example of one of the technologies that do container as a service. Just what I wanted to show you is all the architectures of these products have the same thing. Basically, you have one master or several masters that are handling the capacity planning, the deployment of the containers on in the Kubernetes case, which is the main technology for the container as a service. They are called minions. So basically, one or more masters will handle the resources here, but also the load balancing from the outside world toward these technologies. So that's what we call resource aggregation. You don't see these different servers as different services, but you can actually sum all the resources from these servers as a whole, and just tell the masters, well, deploy Jahia DX number 5 somewhere, and master will determine the best server to receive it based on the available memory, CPU, disk. So you don't have to take care of each individual server. So what technology should you use or look into? Docker Swarm was the initiative of Docker. So Docker is the editor of the Docker technologies, but they have also tried multiple times to create container orchestration technologies to make a profit. That was their original goal. Unfortunately, Docker Swarm, which is edited by Docker, did not make it. It did not got traction and was canceled eventually. So it's dead. So Docker, as an enterprise, has switched to Kubernetes, which was first edited by Google. So it's a Google initiative that is receiving broad attention. Pretty much everybody is using it. I was reviewing the figures last week. I think they have 80% market share. It's supported by Google Cloud, AWS, and Azure. So it's what they call, all of them call that Kubernetes as a service. So it's the serverless technology. Again, you don't take care of the individual virtual machines. You just deploy your containers, and they find room somewhere to deploy them. Red Hat Openshift, it's a fork of Kubernetes. You have to pay for it. It's edited by Red Hat. It adds many interesting features, the biggest of which being a beautiful UI to manage everything. Whereas with Kubernetes, that's command line based, even though it's very simple. And Amazon ECS is an attempt by Amazon to create a container as a service technology. It's receiving traction, but Kubernetes is still the big winner. So key highlights about container as a service technologies. It allows you to achieve highly available architectures because you can spread your applications across several hosts. They do resurrections, meaning that if one host dies, like Jahia DX fails, they'll just kill that container, summon a new one instead, and that's it. In the Docker model, each container is meant to die at some point, so it's not a big thing. It's actually part of the lifecycle of a container, but it's also meant to recreate as soon as possible a new container to replace the old one and get back to normal. Self-service panels. So most of the container as a service technologies have self-service panels. Management APIs. So most of the time REST APIs, but also command line for you to automate everything. And it comes with lots of package applications, like all the types of databases, whether you need Elasticsearch, MariaDB in cluster, all that kind of stuff. It's already prepackaged, so you don't have to package it. Tomcat, WebSphere, all the application servers are also prepackaged, so you can already have beautiful clustered infrastructures without doing anything except for installing Kubernetes or OpenShift on your data center. So how to leverage a container as a service with Jahia? Well, the first thing that you have to do is wait a little bit because we're in the process of supporting it. It should arrive by the end of the year, but we still need to validate everything, make sure that we don't have performance issues, and also document it. We don't want you to go in production without any good documentation about it. So we'll provide nice documentation on the best way, on the best course of action. We also need to train our teams internally, our support team, solutions architect team, to support you on your usage of Docker. Small thing also that we need to take care about, the upgrade. As you may know, at the moment, Jahia needs to be upgraded with the fix supplier, which is a piece of Java software that you need to execute against each node. We don't want that in Docker. What you want in Docker, if you have an infrastructure with a certain version number, you want to shut one node, replace in a certain version, replace it with the version n+1, and do that for each server. Once you are done, once all your containers has been upgraded, your infrastructure is upgraded. So we'll release that so you don't have to use the fix supplier. And yeah, train our teams. In 2019, and we'll do that first thing in Q1, Q2, we'll support Kubernetes and Openshift, also provide documentation, also provide blueprints, meaning that a pre-packaged application for these two container as a service technology, so that you don't have to reinvent the wheel each time. So it's going to be pretty much plug and play on your infrastructure, and you will be able to leverage easily Amazon, Azure, Google Cloud. Do you have questions about that specific part? Yes. The question is where are stored data? Docker has that concept of volumes. So inside a Docker image, everything is meant to be temporary, meaning that if you kill one Docker image and restart a new one, well, you've lost your data. However, Docker supports volumes, meaning that you can mount a directory or several directories inside your Docker image on your file system. That file system is going to survive your destruction of the Docker container. So of course, we're using that for the database, but also for all our products. That's a very good question. Yes, so the Jahia indexes is something that we need to recompute every time we spawn one new Jahia DX node. Yes, for the moment we're storing it. We have an evolution in the roadmap that will benefit all of our clients, which is the automatic synchronization of the indexes over the network when you plug a new node to the server, meaning that if before it needed, I don't know, 4 hours to instantiate a new node because the index processes took 4 hours. Now it's going to be a network copy, which will take 2 minutes in every case. So the instantiation of new nodes will actually take 2 minutes, which would greatly benefit auto-scaled infrastructures, of course. Yes?
You have said that for an upgrade there will be no fix supplier, but how do you upgrade the data then?
So to upgrade the database, how Jahia works today, when you apply the fix supplier, so when you upgrade the file system, the fix supplier also deploys database scripts that are executed the first time the machine restarts. So we'll do just that. In the Docker image, we'll prepackage all the migration scripts. If you deploy the container on a database that is on the same version, the scripts are ignored. However, if it's not the same server, we'll just apply these database fixes. So that's what we call auto-upgradable Docker image. It's a fancy name for something that is stupid but works well. Yes?
About upgrade, so you don't want to have downtime.
Yeah.
You still have to duplicate. That's what you upgrade with the Docker image?
Yes. Usually what we do is, I don't remember the specific name of that, but you have two databases, your original cluster, and no servers deployed on the copy. Then you just remove one node from the original database, database. You plug it to the new instance, so you have your old cluster upgraded non-upgraded but one node, and one node upgraded, and you add that node to the load balancer. So the load balancer is going to be directing traffic to both clusters, which is not a big deal. Your website will always display the same way, so it's not a problem. And you do that until you don't have nodes on the original cluster. So remove one, plug it to the new server, it's been upgraded, and then remove another one. And when you don't have servers on that side, it means that everything has been upgraded, and you can just dump the original database, and you've upgraded everything without downtime. So yeah, that's a good question. We have a deal with our customers. No matter the upgrade, we're never going to change the way your site looks. What you might have to do, though, for the major versions is you will probably need to upgrade your modules to adapt to new APIs, for instance. So between the time you allow traffic on the new cluster, you will need also to upgrade your modules there. But the same strategy can really apply, except that you need to upgrade your modules. No. Anyone else? So just going back here, I'm pretty sure that all of you can imagine how much can go wrong with everything here. Say you want to scale your platform, but you don't have servers left, or the disk space is going full, and you're trying to scale your cluster and crashes with a fire and fury, to quote a great philosopher. So everything can go wrong here. And for you to be able to really anticipate the issue, you need a great monitoring tool. And that's a very good introduction for Daniel Moher, which is working at Datadog, our beautiful monitoring partner for the cloud offering, but also for on-premise clients, who is going to talk about monitoring, observability, and Datadog. So thank you.